Hi everyone, my name is Radek. Welcome to my presentation where I'll be talking about our experience with using both the Apache Airflow and Apache Druid at Skimlinks. I will focus on lessons learned so you don't have to make the same mistakes we did. Both Apache Airflow and Apache Druid have been working really great for us, for which we are really grateful to the open source community. And the goal of this talk is to give back to the community and share experience about Airflow and Druid so others don't have to make the same mistakes. I will also try to include some stories from the trenches and problem we experienced and solved on the way. A bit about myself. I'm a chief architect at Skimlinks, where I focus mainly on large-scale data analysis and data infrastructure type of problems. During my career, I worked on building data engineering solutions for many enterprise companies, including, for example, OpenX, Orange, A4G, Kantar, Moore Capital Management, and often during those projects, I had to deal with a lot of data scalability issues. Most important, I was in charge of the integration with the BigQuery, Airflow, and Druid at Skimlinks. And when shit hit the fan sometimes, I was often the one to clear it up. So this talk is a story of how we migrated from Elasticsearch to Druid. I also assume here that you will learn a lot about Druid optimization on other talks that are taking place during the Druid Summit. Therefore, I will mainly focus here on how we use Airflow together with Druid, but without going too much into the Druid details. So let me tell you first a bit more about Skimlinks. Our technology helps publishers to monetize product links in commerce-related content and earn publishers the share of every sale. Together with our parent company, Connexity, we help our customers to monetize over $3 billion e-commerce transactions in 2020. Skimlinks works with over 60,000 publishers and about 50,000 advertisers and merchants. And as you can imagine, we have to deal with a lot of traffic. Our data engineering team works with hundreds of terabytes of data, and we integrate with many external APIs across all different affiliate networks. In other words, as you can imagine, plenty of interesting data challenges that we have to deal with. Skimlinks is part of the bigger organization, Taboola, and together we have more than 2,000 employees. In Skimlinks, it is around 70 people working, and we are still growing. By the way, we are hiring data engineers, so hit me up with your CV if you like what we work on. So a couple of years ago, we decided to modernize our entire data stack. First, we moved from Hadoop to BigQuery, and recently we migrated from Elasticsearch to Druid. Our entire data pipeline is managed with the help of Airflow. And Airflow allows us to create the data workflows, schedule them, and monitor them. So why Airflow? Indeed, I will cover the three below. So the first one, which is very important for us, it's written entirely in Python. Skimlinks is a Python shop. We write, probably 90% of our tools are written in Python. Python also is a language of choice for many data engineers and data scientists. And we really like the Airflow so-called code-first approach, where you use the code to generate your DAGs, or so-called directed acyclic graphs inside the Airflow. It also has a great open source community. So chances are that whatever problem you're trying to solve, someone else might have already solved it for you, and you can just reuse already available components. It also has modern user interface with such features like real-time log, so you can see what's happening in your task at any given time. You can very easily retry any task inside your Airflow. And you also have access to data profiling, so you know if something goes slow, you can tell why this is the case just by looking at the data profiling inside the user interface. Also, it works very well with the Kubernetes. We are actually using it together with, well, we are using a managed Airflow solution. We run everything on the Google Cloud and therefore are using Google Composer. AWS, by the way, has something similar. It's called Amazon Managed Workflows for Apache Airflow. So if you're looking into using Airflow, you don't have to necessarily spend a lot of effort and set up the Kubernetes cluster yourself. You can just use a managed solution from Google or AWS. If you have such an option, I definitely recommend going with the managed cluster because it will help you to save a lot of time. So here is an overview of our data stack. On the left, you can see our data sources. So all of our event level data goes in real time into the PubSub. And then we have Cloud Data Flow, which is a managed version of Apache Beam. So we have some Apache Beam processes that consume the data from the PubSub and push that data in real time into the BigQuery. In addition, we also write some data into the Google Cloud Storage and also consume that data in batches and push it also to the BigQuery. So BigQuery is our single source of truth. This is our data warehouse. This is where all of our raw data ends up. We do all the aggregations here and so on. In addition, we also have a transactional database. We use MySQL for that, and we sync some transactional data from the MySQL to the BigQuery, as well as some dimensional data. So, list of the advertisers, list of the publishers, all the different dimensions. And all of that is orchestrated with the Apache Airflow. So Apache Airflow is going to help you essentially schedule all your batch processes. It's not going to help you if you have a real-time process. So I mentioned that we have, for example, some real-time Apache Beam that reads the data from the PubSub and sends it to the BigQuery. That's a real-time process that runs all the time. So Airflow doesn't really have anything to do in here. There is no need to automate any batch processing in here. And the way we are using Airflow actually with the BigQuery is we have that general pattern that, as I mentioned, BigQuery is our data warehouse, and then we build all of our aggregated tables inside the BigQuery, and we only push the aggregate tables into Druid. With some exceptions, we also push some smaller data sets on the event level data, but mainly we use Druid for the aggregation data. So before Druid, I mentioned that, well, this is a talk about the migration to Druid. So before Druid, in this place in here, we had Elasticsearch. And generally, Elasticsearch was working pretty well for us, but it had some problems. So for example, Elasticsearch was slowing down the cluster a lot whenever we were ingesting the data into the Elasticsearch. Reindexing longer period of data, like bigger chunks of data, would very often like completely kill the performance of the Elasticsearch. And like we have to deal with a lot of reporting analytical queries. We handle hundreds of thousands of API reporting calls that are pushed to Druid. So Druid is handling all this traffic pretty well. Elasticsearch was actually struggling quite a lot. So some of you here might be already maybe using Druid for real-time data. This is something that we are planning to start using at some stage, but so far it hasn't been a business priority. So before I mentioned that we also migrated from Hadoop to BigQuery. BigQuery is our data warehouse, and BigQuery generally works very well for us because it can handle large and complex SQL queries. The Druid can't really do that, and now it's important to remember that when we compare these databases, they're very different. So Druid is not a data warehouse. We used Hadoop for that earlier. However, what was really surprising for us is that BigQuery can work pretty well as an analytical database. So we use actually BigQuery to serve also some on-demand queries that are coming from our reporting API. BigQuery, I would overall say that is so good that it almost takes away all the fun. All you have to do really is just optimize it on the amount of data. So generally, whenever you're running some query on the BigQuery, you just mainly have to worry about how much data this query is going to process. And no matter what you're going to do with that data, the price for the query is going to be the same. It's a very similar solution also to Amazon Athena. So both Athena and the BigQuery have exactly the same pricing, where you pay $5 for terabyte of processed data. So we try to optimize a lot of reports in such a way that they shouldn't they shouldn't process more than around like 100 megabytes of data per query. As you can imagine, for $5, you can run a lot of such queries. However, pricing definitely was a factor in here, because BigQuery is doing pretty well on majority of our queries, but when you throw like hundreds of thousands of queries on the BigQuery, it quickly can become expensive. So when we compared the cost of running the same queries in Druid and the BigQuery, we realized that BigQuery is actually 10 times more expensive for us. So pretty much it was, it was a fairly simple decision to migrate all those reporting queries to Druid. So before using Druid, we used Elasticsearch as an analytical engine, as I mentioned. And Elasticsearch very often gave us quite a lot of distress. You know the type when you wake up during the night, services are down, and you don't even need the coffee to wake up, because you're just like madly fixing everything. And Elasticsearch definitely caused a lot of that stress. Adding new tables to existing large Elasticsearch indexes was rather difficult. As I mentioned, indexing the new data was slowing down everything. And then the next thing you know is that the PagerDuty calls you during the night. And I mean, it was fun. So we did a lot of optimizations on the Elasticsearch, but generally we didn't see how this database can scale for us 100x. That's why we started looking for alternatives. So we use Druid as an ad hoc analytical engine, which in our case directly replaced Elasticsearch. And it's been working extremely well for us. So Druid is very fast for things such as filtering, slicing and dicing. I would even call it blazingly fast. It also offers SQL support, which helped us quite a lot. It was, well, most of the engineers understand and know SQL, so it was fairly easy for us to create the new reports in Druid. While with the Elasticsearch, you don't have a SQL support. You have like this very specific Elasticsearch query language, which you need to learn separately. Saying that Elasticsearch is great for other things like full text search. It's not too bad for group by queries, but we used it as an analytical engine, and generally for this use case, Druid was working much better. Also, Druid has isolated data imports. So what that means is that whenever we are importing the data into Druid, we just import the data on separate servers. So those servers could be very busy ingesting the data, and there's historical servers that are handling the queries in real time in the meantime are not going to be slowed down at all by the ingestion process. So ingestion overall is fantastic. Also, Druid compresses the data for you. And in our experience, we've seen that the compression is like up to 8 to 10 times, depending on the type of the data, which really helps quite a lot, especially after we migrated from Elasticsearch to Druid. We've seen that quite a significant data reduction. So just to give you some statistics, we have around 3 to 4 billion rows in Druid overall. And all of those rows, that's, as I mentioned, mostly aggregated data. It takes less than 250 gigabytes of space, so of unreplicated data, more like twice as much replicated, because the data needs to be replicated on multiple servers. We use around 10 servers for to host all of this data, and generally it's working extremely well for us, with some exceptions. I wanted to mention one exception in here. Recently, we released a new reporting API that works on top of Druid, that just completely killed our Druid cluster. Some queries would just freeze the entire cluster for 1 to 2 minutes. It was essentially like a very large table with high cardinality columns, meaning a lot of unique values within those columns. And we were doing the group buys on multiple columns, including those high cardinality columns. So turns out that this is something that is not working particularly well for Druid. Perhaps we can optimize Druid a little bit better for this use case, but the vanilla version that we are running wasn't doing particularly well on this type of queries. So we solved the problem actually in such a way that we just ported back this particular report into the BigQuery. It took us probably just 2 or 3 hours of coding, and the API works great again. So the main takeaway, I would say, from the comparison of those 4 databases is that there is really no single database that fits all the needs. So you have to keep in mind that different databases are optimized for different use cases. If you need a transactional database, use the transactional database. BigQuery is great for data warehouse and some ad hoc querying, while Druid works really well for the ad hoc reporting. So let's dive into some of the ETL processes and talk about the best practices that we developed over about a year or so working with Druid. So as I mentioned, the BigQuery is our data warehouse, and we aggregate everything in the BigQuery and export it into the Druid. So there is really no need to do any type of ETL in Druid itself in our case. And the thing that works really well for us, and it's kind of a must actually to do with the Airflow, is to develop your DAGs, your Airflow DAGs and Airflow processes in such a way that they're independent. So what that means is that every task should be repeatable. So for example, if you rerun some particular task twice, you should not end up in your database with twice as much data. But if you, for example, import the data into the same partition, you need to override the partition. So this is very useful because things tend to fail sometimes in the production. It happens that the Google Cloud might have a bit of an outage, or something else might go wrong, and you have to rerun some processes. So high dependency definitely is going to help on that. Another thing to keep in mind is, in our experience, putting too much load on Airflow usually would cause us some problems. So we tend to only put very light loads on the Airflow. So CPU wise or IO wise, it's better to let Airflow organize and orchestrate the work that is running outside of the Airflow cluster. So if you have to run something that is CPU heavy, you just use something like Kubernetes operator, for example, or SSH operator, where you SSH to another server and you run all the heavy computations somewhere else rather than on the Airflow. Another thing that works particularly well, especially with the Druid, is the auto-scalable middle managers. So I mentioned that Druid ingestion is incredible because it doesn't slow down all the live queries that are running on your cluster in the background. But another great feature about the ingestion is that you can scale up automatically or scale down the servers that are doing the ingestion for you. These are so-called Druid middle manager servers. So we created the system in such a way that we just created the Google instance group that can scale up or scale down. And we implemented this in-house actually first. So the process works in such a way that we create the aggregate, and whenever we want to export that aggregated data into the Druid, we increase the number of servers on the instance group. The middle managers, are automatically created. The middle managers ingest the data from the Google Cloud Storage into the Druid. And the moment the ingestion has finished, the middle managers are automatically closed down by Airflow. So this way, you don't have to keep so many servers around, and your costs are going to be much lower as a result as well. Funny fact, after we implemented it in-house, Druid introduced the same feature. So now you can just use the auto-scaling middle managers that are part of the open source Apache Druid. So takeaway from this slide, I would say, is focus on repeatability and scalability. And if we can do something better at Skimlinks, we should probably migrate to the new, use the official Druid solution for scalable middle managers rather than continuing using our own. Another example of the ETL best practices that I wanted to show you in here is the automated integration test. So this is particularly important whenever you are doing some migration. So when we migrated from Hadoop to BigQuery and then later from Elasticsearch to Druid, we had to make sure that the new data sets that we created in the BigQuery or we imported into the Druid are matching 100% to the original data sets in the Elasticsearch or Hadoop. And the integration test is something that helped us to achieve it. So let me show you, let me take you a little bit through this code. So we created, on the right side, you can see the BigQuery compare SQL results operator. This is a custom operator that we created that takes essentially two parameters. So it takes two SQL queries on the input. Then it creates the pandas data frame as a result of running each of those two SQL queries. And then it uses the pandas assert frame equal function to make sure that both of these data frames are equal. If they're not equal, then you get error. And on the left, you can see the example of actually running this operator inside the Airflow. So generally, the pattern that we are using is that for every single Airflow DAG, we create a corresponding test DAG, and we use that test DAG on the local Dockerized version of Airflow to run the integration test and run the actual DAG before deploying it to production. Excuse me. So In here, you can see that we have two SQL queries. We have a query that queries the warehouse, the new warehouse table, and the query that queries the expected warehouse. Generally, these queries are, we use Jinja templating, so they're roughly similar. They just query different tables. The one thing to kind of be careful about in here is make sure that whatever queries you are putting in here are not going to select too much data, because the data is going to end up in both of the data frames. So you want to make sure that your data frames are going to fit in memory. So we tend to mainly do like a summaries and comparisons. So for example, we would do like sum of all the revenue from one table and compare it to the sum of the revenue from the other table, to the select distinct count from one dimension, compare it to the select distinct count from another dimension. And this is generally working really, really well for us. So every single DAG that we do, we create integration tests for it. Also, I wanted to mention another tool that we installed after migrating to Druid. It's called Turnilo. So I wanted to do like a big shout to Turnilo. If you're using Druid or you're planning to use Druid, I highly recommend it. It's a business intelligence tool that is extremely easy to use, especially by non-technical users, since it doesn't require any SQL knowledge. Originally, the Turnilo was open sourced by Imply. It used to be called Pivot, and now is supported. The same tool is supported by Allegro, which is the Polish biggest auction service. In Skimlinks, we use few reporting tools. We use Tableau, Google Data Studio, some customized reports. And to be fair, like when we installed it first time, we didn't have some big expectations. But Turnilo was extremely well received by our users. The internal users all absolutely love using it. And now, thanks to Turnilo, everyone can do the exact type of report they need without having to wait for engineering team or analysts to help them with. So even people who do know SQL prefer often to use Turnilo. So I definitely recommend it. It's worth giving it a try. It's fairly easy to set up and works very well. Everyone loves it. Few words about our infrastructure. I already mentioned the scalable middle managers. They definitely help us to reduce the cost of the Druid. And as I mentioned, if we could do something differently right now, we would rather use the same feature that is already available in the open source Druid. And if you are setting up the Druid infrastructure, you can also consider maybe using some managed services. So we set up the Druid using Terraform and Puppet, which is generally working pretty well. However, right now, if I would start doing it again, I probably would go with something like called Google Dataproc, which essentially allows you to set up. It's comparable to Amazon EMR, so you can set up a new cluster of servers, and you can just instruct Google to install Druid for you on this. Back in time, when we created Druid cluster, we didn't really have such an option, so we didn't go with the Dataproc. Also, automation is of course very important. Wanted to mention that we are automating not only the infrastructure but also the Druid, so-called Druid lookups. So Druid lookups is the way for you to map from ID to corresponding dimension. So for example, let's say that you want to you exported the aggregated table that has the IDs inside, and you want to map the advertiser ID to advertiser name. You can use that. You can do that very easily with the Druid lookups. So Druid lookup is essentially like a configuration that you can put into the Druid user interface, where you specify that you would like to map this advertiser ID to advertiser name, and you specify your JDBC connection, and you specify which table and which columns should be used for that mapping. So we just automated the deployment of the Druid lookups to avoid, clicking and making changes manually in the UI. In addition, we also automated the synchronization of the data from MySQL to the BigQuery. So we tend to synchronize a lot of tables from our transactional database to the data warehouse. So this is definitely helping quite a lot as well. And the last thing is the deep cloud storage. We are using the Google plugin together with Druid. There is also the Amazon plugin, I believe. So generally, this is working very well for us, because let's say that you want to do the backup of your data. All you have to do is just make a snapshot of the Google Cloud Storage bucket, and here is your backup. Let's say that you want to create a new mirror of your production Druid cluster. All you have to do is just set up the new cluster, copy the data from one bucket to another, and you have a new copy of the production cluster. So yeah, overall, Airflow and Druid have been working incredibly well for us, especially when combined with the BigQuery, where we do most of the heavy lifting on the ETL side. So during all the migrations, I wanted to summarize with the 3 things that made the biggest difference for us and made all those projects successful. I would say the number 1 is the use of the managed or serverless services. So we used managed Airflow, so we don't have to worry about configuration of the Kubernetes cluster. We use BigQuery, which is a completely serverless database. We don't have to worry at all about any configuration of the BigQuery cluster again. And if we would use Druid with the Dataproc, then probably this entire setup would be managed and wouldn't require too much maintenance. No infrastructure means you can spend more time focusing on a problem at hand rather than being buried with all the infrastructure. Unless your DevOps team has time for it and appetite to set up everything yourself, or sometimes you might not really have such an option if you're on premises. But if you work with the cloud, that definitely helps. The second thing is the integration tests. So they helped us a lot as well, especially in cases where we had to have like a fully automated tests to compare the expected data sets to what we migrated. And generally, as a result, the migration from Hadoop to the BigQuery and from the Elasticsearch to Druid went pretty smoothly. We didn't really have almost any problems after migration. So the migrations are not so scary if you have good testing. And the last thing is to use the right database for the right use case. There are no really silver bullets, as probably all of you are aware as engineers. And I'm sure it happened to many of you that you started building some solution in your database. You put all your data into Postgres or MySQL, and then you started using that Postgres for everything, including the reporting. And then the next thing you know is that everything is slowing down, the lag increases, and that's when it might be a good idea to think about some dedicated analytical database. So to conclude, I highly recommend you try using Druid with Airflow. It also works very well with our pattern of usage, where we keep everything in the data warehouse and load mainly the aggregated data into Druid. Thank you very much. So I hope that we should have some time for some questions.
Thank you very much, Radek. I am Charles. I'm a writer at Imply, and I'm taking the Q&A. You folks can add their questions to the Q&A tab. Looks like Peter has already asked a question. He asks, do you have any recommendations for working out schema design when switching over to Druid?
Yes, I suppose it depends what you are switching from, but if you are switching from the SQL table, then from the SQL database, then it's pretty straightforward. The one thing you have to keep in mind is it's good to remember about the clustering. So clustering is something that can help you optimize the queries on the Druid side. So generally, you should probably just read a bit more about that. So the order of columns is quite important in your data schema, essentially, because that is going to define the clustering or the sorting of the data within those columns. So depending on how you order your columns, it could make a massive difference in the speed of your queries.
Thank you very much. Centol asks, at what point did you decide that Elastic is not working for you? Was it query performance, ingestion, or observability?
Yeah, good question. So the story is that one day my CEO came over to me and said, like, Radek, we need a 100x scalable solution. And he was asking whether Elasticsearch can take us there. And we were thinking about this actually for a very long time, and weren't really sure whether we can, like whether Elasticsearch can take us there or not. And to be fair, you can probably just throw 100 times more servers at the problem, and Elasticsearch might take you there. But then we started looking at the alternatives, and it wasn't just the scalability; it was also the support for the SQL queries and the performance of the analytical queries as well. So support for the SQL queries was very important for us because, so actually one thing I also might mention is that in our use of the BigQuery, we have this pattern where we tend to create the table first in the BigQuery, and we power a lot of our new reports directly from the BigQuery. And only if we notice that the cost is a bit too much, we migrate that report from the BigQuery to Druid. And since both of the databases support SQL, this is really easy right now because all we have to do is just create exactly the same schema in Druid, ingest the data, and if you keep the original query in the BigQuery, like if it's fairly simple query, then you can port it without too many issues into Druid. One thing you have to watch out for is joins and generally complex SQL queries, because that doesn't work very well with Druid.
Thank you very much. We have another question. Airflow to ensure lossless ingestion and do real-time data availability?
Right, good questions. So for the lossless ingestion, so we do two things. The first thing is the integration test that I mentioned earlier. So whenever we define the new DAG, we always create the integration test for that DAG and compare the expected data set on the very end. In addition, the data engineering team developed recently a great feature where we actually test. So we ingest all the data into the Druid, and then after the ingestion, we have one final one final task that actually tests the data that was already ingested, just to make sure that everything looks and behaves as expected. So we have like a two ways to check that. And real-time data, we don't really push the real-time data into the Druid. Funny enough, we are actually using BigQuery for real-time queries right now. So I cannot comment too much on that.
All right, thank you. The next question is interested. Ashok is curious to know why you chose Airflow and not Apache NiFi or NiFi in this case.
Well, so I don't know enough about the Apache NiFi, I'm afraid, so I cannot really comment on Apache NiFi. I used a few other tools in the past, but I prefer not to really, call the names because it would be maybe a bit unfair for other ETL tools. Like, there's no silver bullet. So there are tools that might be better for one use case. There could be some other ETL tools that might be better for someone else. We are the Python shop, so Airflow is working really well for us, but some other company might not have any Python engineers. So maybe, some different type of ETL tooling might be better for you.
I think that's a fair answer. Thank you.
Thank you.
Any more questions for Radek? I wanted to say, this is not a question, but I enjoyed your presentation and I thought your illustrations were fantastic. Those were really great.
Thank you very much. Thanks a lot.
We have another question. Do you use Imply Clarity or other tools for APM, such as Datadog?
So we do not use any other Imply tools. It's something that we were considering around the time when we started setting up the clusters on Google Cloud. However, back in time, Imply was supporting AWS, but not the Google Cloud. So in the end, we decided just to go with with our own solution. So did not use any other Imply tools, I'm afraid. And the Datadog is something that we are very strongly considering actually of using.
Are you doing observability and monitoring of the system at this point?
Yes, so we have a lot of monitoring in place. I removed it actually from my slide because it would be too busy, but we push a lot of logs to the Google Cloud monitoring. We have some alerts and defined on top of them. So whenever something goes wrong on the server, we will be notified about it quickly. We have it connected with the Slack alert. So whenever something goes wrong, we receive the Slack alert. And also have some pager duty configured on top of Druid as well. So in case something goes really, really bad, someone from the DevOps team is going to receive the call about it.
Thank you very much. If no further questions in the Q&A, if you have if you have anything in summary or any last mention, you're welcome to make it. And then we'll go ahead and wrap this session up.
Yeah, maybe I would just really reiterate what I said earlier, which is that I highly recommend you trying using Druid with Airflow. It works very well for us, and yeah, good luck.
Thank you so much, Radek, for a great presentation, and thank you to all of the attendees. Really great questions for this talk, and we look forward to seeing more from you. Thank you so much.
Thank you very much. Bye.